ecosystems, we gotta use a certain calculation to see what the biodiversity is, and then we can actually compare it to other ecosystems. So I'm gonna show you guys what the calculation is. You're gonna calculate your biodiversity that you guys saw when you went to Lake Cunningham or when you went to Alum Rock, and then we're gonna compare with the other groups and what numbers they got as well. Sounds good? So the equation. So the equation that we're going to look at is called the Simpson's Diversity Index. And what that's doing is we're taking into account species richness and species evenness. Thank you guys for taking notes down on your papers. We're taking into account species richness and evenness, and we're using that to calculate how biodiverse our ecosystem is. So what I definitely want you guys to write down as part of your notes is what's in red over there. When you do your calculation, when we do our calculation, you're going to get a decimal, and that number is going to be between 0 and 1. That number is always going to be between 0 and 1 when you actually plug in your stuff into the equation. And if it's closer to 0, like imagine 0.1, right, or 0.2, that means that your ecosystem is not super biodiverse. But if it's a number that's closer to 1, imagine that you calculated and you got something like 0.8 or 0.9, right? That's closer to 1. That means that your ecosystem is really biodiverse. And as we saw last class, you guys noticed that when our ecosystems had more variety, were more biodiverse, they were more likely to survive. So this is one of the pieces of evidence that you're going to use to prove to people and prove to each other why your ecosystem is going to be able to survive, it's resilient, or why your ecosystem is in danger. So let's take a look at what the equation actually is. This is the equation, and when you see it, I don't want you to get scared about it looking too complex, because we're going to take it step by step for how to use it. Okay? So your equation is capital N, and the capitals and lowercases matter here. Okay? So it's capital N. There's no space in here, right? So is it addition, multiplication, subtraction? Do you know? Multiplication, right? If there's a subtraction, we'll see subtraction, but we're not seeing that. So N times capital N minus 1. And capital N here stands for species richness. And then we're dividing that by lowercase n times lowercase n minus 1. Lowercase n stands for species evenness. So we're going to want to calculate this for each of our different species. Add those up, and then divide it by that top number. Thank you guys for writing this down. We're going to look at this example. We're going to do an example together. And then you guys are going to use this to then calculate your guys' biodiversity using the data table we put together last class. Thank you guys for 100% engagement here.
It's cold. I hate this. I hate this sometimes.
Give me a thumbs up when you have the equation down and you're ready for us to do the example together. Thumbs up when you have the equation down, you're ready for us to do the example. Thank you, Oscar. Joshua, are you ready? Jackie's team, just checking in. Since her headphones out, are we all doing the write-up right now? Austin, can you check in with your team, please, and have a seat with your team when you're doing the write-up? Sorry, Aiden. Can you sit with your team, please, and do the write-up? All right, guys. So let's do the composition. So for the top one, right, we're looking at species richness. What is, this way, what is the species richness in this ecosystem here? Can you guys see? What is species richness again?
Total amount.
Yeah, and what is the number that we're seeing up here? 5, right? So we're gonna plug in 5 anytime there's a capital N. So let's go ahead and do that on your papers. You can follow along with me or you can write this on your own.
It is so cold.
So, whenever there's a capital N, I'm gonna write in 5. So let's erase.
Oh, Jesus.
So Leah, what's 5 minus 1? 4. Volunteer. Any volunteer? What's 5 times 4?
20.
20. So the top number is going to be our numerator. I know this is sounding like kind of a math class right now, but we're going to be able to use this soon. And then let's calculate the species evenness. So the way I want you guys to do this with your calculations is make sure we're labeling what animal we're talking about, okay? For example, in your notes, you should write what I'm doing on the board. Let's calculate the species evenness for deer, right? So I'm going to use 3 times what? What should I plug in here? The parentheses. So 3 times, and what should I put in there, in the parentheses?
Oh, it would be 3.
3 minus what? 1. Good. Alicia, what's 3 minus 1? No? Janae, 3 minus 1?
4.
2.
I mean, fuck. I keep thinking it was. I was thinking it was something else. You said 4
Brian,
minus
what's 3
1.
times 2? 6. Right? So now I'm going to do that with each of my animals, and we're going to add it up. So I know raccoons has the same number, right? So it's going to equal 6. Let's do, thank you, Alicia. Let's do eagles. So for that one, I'm going to do 2 times 2 minus 1. What's 2 minus 1, guys? Everybody?
1.
1. What's 1 times 2? 1 times 2?
2.
2. So you're going to keep doing that, right, until you get 12. Yeah, and then we're going to add this up. Oh, I'm forgetting 72. And then when we add all this up, that gets you a total number of 98, right? That's the number that we then bring up here, and we divide 20 by 90.
Wait, how did you get 72?
Because 9 times 9 minus 1, so that would be 8, right? So 9 times 8, and you can either think about using your mental math or use a calculator. So 9 times 8 is 72. Okay? So with this, remember that you're dividing the smaller number by that bigger number. You're going to get a number that's between 0 and 1. So notice when we did that up here, the number that we end up getting is 0.2. So let's see how we're actually going to use this number then, okay? Why is this number, why is this decimal even important? So I'm going to be switching to the next slide. Take a look at these 3 pictures up here. Just take a look at the pictures and the numbers at the bottom.
There's Nemo.
I'm going to have you guys vote in a second, and I want to see everyone's hands taking a guess. Which ecosystem has the highest biodiversity? Okay, so in a minute, I'm going to have you guys raise your hand or give a thumbs up near your chest if you're not sure. But raise your hand if you think it is the redwood tree ecosystem with 0.2 as the number. Do you think that they have the highest biodiversity? You're going to raise your hand or give me a quick thumbs up. No one? Okay, raise your hand if you think it's the desert ecosystem. Highest biodiversity. You think it's the first one? Okay, and raise your hand if you think it's the coral reef ecosystem. Alright, so here's the thing. Coral reef has the highest number of different animals, right? But let's look at which one has the highest number. Which one has the highest number? 0.2, right, is the biggest number here. So actually,
Oh,
Yeah, point 20. So sorry. Point 20. Redwood tree ecosystem has the highest biodiversity. You guys see that? So notice how we can use that calculation. When you guys are working, looking at other teams' data, you can see who has the smallest number, who's having the biggest number, and what does that mean about how biodiverse the ecosystem is. Does that make sense? Okay. Thank you, Leah, for asking that clarifying question earlier about the calculation. That was helpful. All right, so at this point, I want you guys to work with your teams. I have the instructions up here, but before you guys go, we're just going to stay here. So I'm going to have you guys started with the equations here. You have a couple options for how you're going to do this, all right? You can maybe split up some of the work with your team so different people do different calculations. So let's say that you guys have a lot of different animals, right? So maybe Modesty would take 2, Janae would take 2, and Alicia would take 2. And you can split up the work.
Alright.
Oh. Or Gabby does all of them, and then if I do all of them, I do we're gonna split up the work so each person is doing the calculation. Make sure that you check your work with your team to see that we all have the same answers, alright? So go ahead and sit with your teams. You can go ahead and sit with your teams at this point. You guys can stay here, I think that would be good. And we can start doing the calculations. Cool? I'm gonna give you guys 10 minutes to work on those calculations.
That's my notes.
You gonna do what?
No. I submitted this.
You now work on why'd you mess it up? So I don't memorize it?
Wait, Miss Ramachandran, I did this.
Where?
Right there.
Look. So are we taking 2 by 2?
So, do you guys know how to get started? Yeah. Let's take a look
It's
at
just
our
what she did on the board.
Janae and Madi, you guys have your...
She's not yelling at you.
Let's take a look at our data tables right now. Janae, can you show her the data table we started last class? Madi, I need your help getting the...
Oh.
You guys have your data tables open? Perfect. So with your data table, and you're going to want to look at their data tables.
Mine deleted.
Can one of you, Gabby, can you share it with both of them?
Yeah.
And then we're going to start by maybe...
Is it? It's on doc sheets? Doc sheets.
Gabby, can you start by calculating
Google
the top
Sheets.
number, your capital N minus capital N minus 1. And then Rihanna, maybe you can start with a couple of the ones to calculate the bottom. And Aaliyah, you can start with a couple of the ones to calculate the bottom part.
I'll do the banana slugs and the red trees.
But you're using your ecosystem data now to do the calculations.
I'm so confused.
Can you share your data table and show her what to do?
Here.
Can you share it?
No.
So I'm gonna let him go first.
Okay.
But I do need you guys to get started with your calculations.
I'm more serious.
Thank you for waiting patiently. Can you guys open your data tables that we started working on last class?
What? I was in the other
So
side.
that's why I need Modesty to share it with you.
She has it. It's so cold in here.
Alicia wasn't there last class.
More than just Sinead, because you were in there. That's the reason.
Okay, well, she moved the.
This is what you sent me? You're supposed to send me the that. Okay, it's there. It's there. On my whole computer. Good.
I forgot about that.
No, it's not good. Could have broke my ear.
I don't know what side I'm at with you.
Then we're gonna actually go to
Oh, that.
do you remember? Can you pull that up and share that with your teammates?
We just did it.
Or one thing.
I was like,
Do you understand how the equation is working? So you and your team are going to do that calculation that makes your ecosystem.
I saw.
You want to check in real quick? When you're going to go to your Google Sheets, remember?
You're never gonna do the thing.
Are you going to video?
Huh?
Are you going to video?
My outfit's in here.
Yeah, remember how you
Wait,
made
I have to stay here.
So you're going to do the same calculations?
Yeah, I have to help her.
Oh, you're doing the whole
You
thing?
can split up the work.
She's
Where is
actually
that at?
in the in my cousin
For
Miss.
the
What's the purpose room?
we did it here.
Mobile 13? Oh, yeah.
Okay, thank you, Rihanna, for getting started with the calculations. So we need to be on the document that he's on.
Oh yeah.
So Brian, can you have your team get started with the calculations using your ecosystem data?
About the numbers, about the things that we saw. That's how I was checking. I didn't write down how much I.
So we should all have that data.
Let's go to Google Sheets. I'll be ready with you.
Your data go. Can you look over at Brian's and you can use his computer to do the calculations? Brian, you're gonna have some of yours after this.
But I wrote up. Can I copy this?
Can, but right now I need you guys to do the calculations.
Oh, I can do calculations. Because I was doing it right now, like how much I cost.
So right now we're using his data, but you should all be doing the calculations because this is data from your whole team anyway.
So we're choosing his data, right?
So then your guys' data should be the same. You didn't go at the same time?
No, remember I went different times. Yeah, he went first and then I went.
You found it, Janae?
So then you guys can combine your data, but let's start the calculations. So you have your sheet to put your data together.
So for this, like,
The sheet where you wrote down the different things that you saw.
No,
Look for that and let's get started with the have you guys in a minute switch the tables are done so they can. Alright guys, teams that were working on this side of the room, I now need you guys moving over here. We're now going to be doing lesson on calculations. Teams that are working on this side, I'm leaving it up to you guys to work with your teams to do the calculations together. Alright, make sure that the calculation is done.
This is exactly why I don't like having computers because I have to carry too much stuff. Hey, I'm happy, okay? You gonna wait until I got stuff? At least my computer closed. Oh, Gabrielle's cute.
I know there's not much space up there, but if you want to bring your laptops and use that as a table, right?
And I'll be here with
Taylor. And have a laptop on your laps to write.
I'll be Taylor or the dancing girl.
And can you guys make sure you have a pencil or and paper? So